one can find out the age of the fossil. What is this law of radioactive decay? It says that the rate of decay for a radioactive material is proportional to the number of atoms present. Mathematically, if xt is the amount of radioactive material at time t, then the above law can be written as dx by dt is equal to minus kx. Minus k, the negative sign indicates that the number of atoms reduces. In the case of radioactive material, the number of atoms reduces. So, because of that we have minus k. Suppose x0 represents the initial amount of radioactive material present, then the solution of the equation that can be written in this form. It is in the first model also we have seen the solution the same way. Xt is equal to x0 e raised to minus kt. You can see that when time goes to infinity, xt tends to 0. So, this situation I will explain, I will illustrate through an example. A fossilized bone is found to contain 1,000th the original amount of C14. Determine the age of the fossil by using this solution. We take the half-life, as I told you earlier, that 5,600 years. Half-life means when the substance becomes half, how much time it takes. That is, on the left side x of t will become x naught by 2, half of that, half of the original. So, that is equal to x naught into e raised to minus k, time is 5,600. Then x naught t cancels from both sides and you can obtain k as log 2 upon 5,600, which is 0.00012378. So, the amount of material at any time t is given by x of t is equal to x at 0 into e raised to that constant multiplied by t. Now, we want to find out t actually when the amount is 1,000th of the original one. So, I take x of t is equal to x0 by 1000. Then here also from both sides x naught, x of 0 will be cancelled and time you can obtain as log 1000 upon that quantity. So, which is about 55806 years. So, you can calculate the time. Now, as I told you that the third field where you can use first order differential equation is that of the study of compound interest. You assume that a sum of money is deposited in bank at an annual rate of r. Then the value s of t of the investment at any time t depends on the frequency with which interest is compounded as well as the rate of interest. Now, if we assume that the compounding takes place continuously, that assumption is needed if I want to use the derivatives. So, that is why I have highlighted. So, it is taking place in a continuous manner. Then the rate of change of the value of the investment is equal to the rate at which the interest increases. So, that is ds by dt, I can write it as a differential equation. ds by dt is equal to r into s. Now this is also a variable separable equation, and you can solve it. Actually ds upon s is equal to r into dt, then you integrate it. So I will get log of s is equal to rt plus some other constant. From this I can find out s of t is equal to s of 0 into e raised to rt, where the arbitrary constant is represented by s of 0. So that is the initial investment. So when time t is equal to 0. Now if we assume that deposits or withdrawals take place at a constant rate k, then I can modify the equation to ds by dt is equal to rs plus k. K is the rate. Then if you solve this equation, then I can obtain the solution s of t is equal to s0 e raised to rt plus k by r e raised to rt minus 1. I will get the solution in this form. Now let us illustrate this by using this example. Suppose a person opens an individual retirement account at the age of 25 and makes annual investments of rupees 2000 thereafter in a continuous manner. You assume that the rate of return is 8%. Then what will be the total amount at the age of 65? So here S0, he start account at time t is equal to 0, so 0. Rate is 8%, so 0.8. K, the constant rate at which he is depositing is 2000. And at the age of 65 he want the money, from 25 to 65. So your time t is equal to 40. So I have this equation, s of t is equal to s of 0 e raised to rt plus k by r e raised to rt minus 1. Now s of 0 is 0, then k is 2000, then r 0.08, 8%, 0.08, then e raised to r into t, that is 3.2 minus 1. So I will get the amount after 40 years, rupees 588,313. There is another field where we can use first order equation is mixture problems. What is this mixture problem? There are water purification plants, then tanks where chemical solutions are there. So when you consider these situations, liquid is flowing from to the tank and from the tank to outside. Then what do you want to find out? The concentration of certain substance in it. How much will be the concentration of a substance after a long time in this situation, that liquid is flowing towards the tank and it is flowing out from the tank. Suppose we are given, for example, I am taking, given the amount of salt initially dissolved in a tank of water. Let salt water with concentration Ci pounds per gallon, in 1 gallon Ci pounds of salt is dissolved, then flows into the tank at a particular rate, Ri gallons per minute. So this is the rate at which water with the salt solution is flowing into the tank. Then the tank contents are well stirred, well mixed, and the salt water mixture is pumped out at the rate of C0. gallons per minute. So, at the rate of C0 gallons per minute. Now, the volume of salt water in the tank at any time t. So, this situation I have shown. So, liquid, the salt water is flowing into the tank and it is flowing out from the tank. Then the volume of the solution at any time t is given by this equation. V of t is equal to V of 0 plus Ri minus R naught into t. Now, what is V naught? V naught is the initial volume of the salt water. Then Ri is the rate at which the solution is flowing into the tank, and R naught is the rate at which it is flowing from the tank outside. So, Ri minus R naught is the difference of the rate. So, when you multiply this difference with the time, that is the rate at which the amount is building up inside the tank. That is the meaning of this Ri minus R naught into t. So, the volume of salt water in the tank at any time t is given by Vt is equal to V naught plus Ri minus R naught into t. Now, let us assume that Q of t be the amount of salt in the tank. Then the inflow rate of salt, this is Ri into Ci, because Ci is the concentration, then Ri is the rate. So, the inflow rate of salt will be Ri multiplied by Ci. The outflow rate of salt is R naught into C naught. C naught is the concentration and R naught is the rate at which it is flowing out. Now, we can note that the concentration of the salt in the outflow is the same as the concentration of the salt in the tank, because the outflowing salt solution is from the tank. It is from the tank, that is why. So, if I write C naught is equal to C of t, then that will be Q of t upon V of t, that will be the concentration, amount of salt by total volume. That is equal to Q of t divided by what is V of t? V of t is V of 0 plus Ri minus R naught into t. But the rate of change of the amount of salt, that is dq by dt, what is the rate at which the amount of salt is changing with respect to time? And that is given by inflow rate of salt minus outflow rate of salt. But what is the inflow rate of salt? It is RICI. Then outflow rate of salt is R naught C naught. So, I got d qt by dt is equal to RICI minus R naught C naught. RICI minus R naught C naught I can replace by qt upon V naught plus Ri minus RT. So, I get a first order differential equation, dq of t by dt is equal to RICI minus R naught q of t by V0 plus Ri minus R naught into t, representing, actually this equation represents the rate at which the quantity of salt is changing in the solution. Let us see this example. A 100-gallon tank is initially half full of pure water. Then water containing 0.1 pound per gallon salt is added at a rate of 4 gallons per minute. then the well mixed contents of the tank flow out to the pipe at the rate of 2 gallons per minute. So, inflow rate is 4 gallons and outflow rate is 2 gallons. When the tank is full, it overflows. Find the amount and concentration of salt. This is the question. So, I have initially the volume of the solution, that is 50 gallons inside the tank, because the tank is half full, 100 is the capacity. Ri, the rate at which the salt solution, that is rate of flowing into the tank, that is 4 gallons per minute. So, I use the equation V of t is equal to V of 0 plus Ri minus R naught into T, that is equal to V of 0 is 50, inflow rate is 4 and outflow rate is 2. So, 4 minus 2 into T. So, I get 50 plus 2T. So, I can see that from this that the 100 gallon tank will fill in 25 minutes, because when you put T is equal to 25, so I will get 25 into 2, that is 50. So, 50 plus 50, 100 gallons. So, it will take 25 minutes to have the full solution inside the tank. So, this situation compels us to divide the interval, the time interval, into two parts. One is time interval up to 25 minutes, and then what is the situation after 25 minutes. So, the concentration of salt is, Ct is equal to Q of T divided by 50 plus 2T. C is Q by V of T, that is the formula. Then the equation of mixture becomes dQ by dt, that is Ci into Ri. So, Ri 4, Ci 0.1 minus 2 into Qt divided by 50 plus 2T. So, this I can simplify and put it in a differential equation of form dQ by dt plus 2Q upon 50 plus 2T is equal to 0.4. And this is a linear differential equation.